Picture this. You're trying to run an HDMI cable, just a couple of rooms over, and the signal completely drops out. Or maybe it just turns into a totally glitchy, unwatchable mess.
Right, yeah.
We have all been there. But now I want you to imagine taking that exact same pristine 4K video signal and running it 20 kilometers.
Which is, I mean, that sounds completely absurd, right? 20 kilometers is roughly the distance from downtown Manhattan to the edge of Queens.
Oh, wow.
Yeah, and you're talking about pushing a flawless 4K signal that entire way without a single skipped frame.
So, welcome to today's deep dive. Our mission today is to figure out how this is actually possible. We are looking at a really specific piece of AV tech from HDTV Supply. It's the Avenview FO-HDM-IP4K-SET HDMI Extender over Fiber Optic.
That's a mouthful.
It really is.
Okay.
But we're going to break down how this device completely shatters the physical limits of standard video transmission and, why understanding this matters for you. So to start us off, how do we physically get a heavy video signal to travel that kind of distance? Because with standard copper HDMI, the signal just dies.
Yeah.
It's like shouting your message down a super windy hallway, right? The signal degrades fast.
Right, because copper cables rely on electrical currents, and those degrade really quickly over distance. Plus, they, constantly pick up interference from other electronics in the walls.
Ah, yeah, that makes sense.
Yeah, so this Avenview extender bypasses that entirely. It uses what is called a single-mode fiber optic cable.
Hang on, single-mode fiber? I know fiber optics use light instead of electricity, but what makes it single-mode?
Well, think of a fiber cable as a tiny, highly reflective tube. In standard multi-mode fiber, the light just bounces all around the walls of that tube as it travels.
Like a pinball or something.
Exactly, like a pinball. And it's great for short distances, but over long runs, those bouncing light rays get totally jumbled up and out of sync. But single-mode fiber is incredibly thin. We are talking fractions of a human hair.
Wait, really? That thin?
Yeah. Because the core is so narrow, the light travels straight down the center in a single path without bouncing against the walls at all.
Okay, so following my analogy earlier, instead of shouting down a windy hallway, single-mode fiber is like shooting a perfectly clear, totally uncorrupted laser beam to the next town over.
That is actually a really great way to put it. The transmitter box takes your standard electrical AV signal, it translates it into rapid pulses of light, and just shoots it straight down that path.
Right.
And because it's just light traveling through glass, you get 10.2 gigabits per second of bandwidth with virtually zero signal loss.
That is wild.
Yeah, and since there's literally no electricity in the cable itself, it's completely immune to any electrical noise from the outside world. Plus, it's protected by this really high-end wall-mountable aluminum alloy enclosure.
Which is great. But, okay, sending the video is really only half the battle. If I am sitting in a room looking at a TV that's receiving a signal from miles away, how do I actually interact with it?
Right, like how do you change the channel?
Yeah. Am I supposed to walk 20 kilometers just to pause the movie or change the volume?
Well, that would completely defeat the purpose of the whole setup. So the system uses a feature called IR passback. It supports 20 to 60 kilohertz devices.
Oh, meaning what exactly?
Just means the receiver box by your TV can read the infrared light from almost any standard remote control.
Oh, so I literally just point my normal remote at the screen like I always do.
Yes, exactly. The receiver catches that infrared command, it instantly translates it into digital data, and then it shoots it right back up the exact same fiber optic line to your source equipment.
Okay, that completely solves the distance problem for a single screen. But looking at the sources we have, they use these extenders for massive multi-screen setups.
Oh, yeah, absolutely.
Like sprawling college campuses or giant sports bars. How do you go from one super long cable to feeding dozens of screens?
Well, that is where the networking side comes in. You can connect multiple of these sender units into a managed gigabit switch.
Okay.
And that switch uses VLAN and IGMP support to handle everything.
Wait, hold up, stop right there. You just threw some serious network engineering alphabet soup at me. What are VLAN and IGMP, and why do I need them to watch TV?
Fair enough. Yeah, let's break that down. A managed gigabit switch is basically a heavy-duty traffic cop for your network.
Right.
VLAN stands for Virtual Local Area Network. And what that does is it lets that traffic cop carve out a dedicated VIP lane on your network just for this massive 4K video traffic.
So it doesn't collide with people checking their email or browsing the web.
Exactly. It keeps the video stream totally separate.
Okay, VIP lane for video. Got it. And the IGMP part.
So IGMP is the system that tells the traffic cop exactly who actually wants to watch the video. Because otherwise, it would blindly blast a heavy 4K signal to every single TV on the campus and completely crash the network.
Oh, I see.
Yes, IGMP ensures the video is only routed to the specific screens that are actively asking for it. That's what allows you to scale up to massive systems, efficiently pushing flawless 4K video and up to 7.1 surround sound to dozens of displays all at once.
Wow, so zooming out here, this isn't just a really long cable. For a $499 hardware set, this is a fundamentally different approach to designing AV spaces.
Definitely, you are stripping away all the limitations of standard copper. You're using light to essentially teleport an uncompressed experience across city-sized distances.
It totally solves the logistical nightmare of long-distance high-fidelity transmission.
Yeah, you can put your loud, heavy, heat-generating equipment literally anywhere, completely out of sight.
Which leaves you with a really interesting thought to chew on today.
Oh.
Yeah, think about it. If we can easily push flawless 4K video, instant remote control commands, and heavy 7.1 surround sound 20 kilometers through a single strand of glass with absolutely zero lag,
Right.
how long until physical proximity to our high-end hardware becomes completely irrelevant in our homes and businesses?